JSONB and JSON data type, key differences and what the operators that is being offered and what kind of indexes that we can build on it. So this is typically a kind of OLTP normalized workloads that looks like. So PostgreSQL was received an on-demand to introduce the data type called JSON. So it was introduced in 9.2 PostgreSQL, and later it got improvised. So JSON and JSONB, there are two data types. The key difference between those two data types, so this is basically the NoSQL kind of data, right, that we refer to, or that we store the data in the JSON data type column. So you have a parent node, child node, and the leaf node, right? And the JSON data type, basically, it stores the data as is by doing a syntactical check, right? How we do for the XML. The similar kind of thing will be done for the JSON. The one difference between the JSON and the JSONB is, so JSON will store the data as is, which means that the white spaces, carriage written, line feeds, so etc. will be stored when we onboard our data to the JSON data type column. JSONB is more like, it is in binary format it stores. It will compress the data in a multiple blocks in a binary format, and it will get stored in the background. So here the key differences in terms of storage, in terms of write, read, right? And for the storage, as I said, JSON stores the data in raw format, whereas JSONB, it stores the data in binary tree structure. And it also applies certain mechanism to store that, which is called toast, right? So the performance will come into the picture for the workloads that we write to the JSON and JSONB. So when we write the data to the JSON, it just do a syntactical check. It don't parse the data when it gets stored in the column. Whereas JSONB, it will just, it will also check apart from the syntactical check, it also parse the data and it will get stored. So for read agnostic workloads is the right fit for the JSONB. And here the operators that we can, on a high level that I call it off, these are all the operators that supported for the gene index. If you happen to qualify any of your workloads for these operators to be used, you just follow the recommendations that was called out here. So the important thing here is when you happen to create an index on JSON or JSONB data type, you need to triple check, double check your query access patterns. Because if you happen to choose the JSON or JSONB data type column to be a part of any gene index, right? It requires the 90% of the space of what the original data table that carries. So which means that your index will be quite large. So maintenance will come into the picture and more database resources required. So you have to thoroughly check your query access patterns and take a decision whether to go with B-tree index or gene index. So to the use case that I have worked on, JSONB, whatever the gene index that was created on JSONB versus the binary tree index, it's nearly same is the performance that was given. So but thoroughly check your use case, and before you onboard your workloads and create a gene index, you just check all these things. Yeah, that's all from my end.